Welcome to our webinar on cloud computing using power system analysis. Thank you for joining us, and we're very excited to share with you some ideas for the network planning and operation using network system analysis, power system analysis tools. NEPLAN Electricity is a software tool to analyze, plan, optimize, and simulate electrical networks and will be the focus of this webinar. My name is Gabriela Andrade, and I am a marketing specialist here at GERS. I will be giving a brief introduction, followed by the more technical side of the presentation presented by engineer Leniker Palacios. Please submit any questions you have, and we will discuss them in the Q&A portion of the webinar. So first, we will give a brief introduction of our company, GERS. GERS is an electrical engineering consultant group that was established in 1981. To date, we have completed over 6,500 engineering projects and over 3,700 electrical studies in over 45 countries. On this next slide here, you can see the countries where we have carried out projects from our offices. We currently have offices in the United States in Weston, Florida, and Midland, Texas, and affiliated offices in Mexico, Colombia, and Chile. Additionally, we have attached a handout of our brochure for you to learn more about our company. For this presentation, we will be accompanied by engineer Leniker Palacios, the Director of Power System Analysis Tools here at GERS. He will be presenting information, especially from an electrical engineering perspective, focusing on how power system analysis tools can help with the network planning considering new technologies on the loads and generation system. So we will now begin with the technical side of the presentation. Welcome, Leniker. You may now begin. Hello, Leniker. Are you there? I can't seem to hear you.
Yes, good afternoon, Gabriela. Can you hear me?
Yes, I hear you now.
Okay, perfect. Thank you very much, Gabriela, for that introduction. Good afternoon to all attendees to this webinar regarding cloud computing and how this concept is now applied for the electrical networks simulation. This presentation will be oriented to the main capabilities that we are finding regarding the cloud computing. We know that to date, many utilities, many industries are migrating to the cloud. What is the reason of that? Why we can integrate this kind of technologies regarding the database management using the cloud services in this world where finally we are finding how the digitalization are playing an important role on the network operation and the network planning in this case. This is the focus of this presentation. So I have prepared here 4 general topics. However, these general topics, we will open specific themes that I think that they should be very important to explain in this webinar. Because if you, after this webinar, will be understanding what do we mean when we speak a real client-server architecture, we will be providing you the best way for understanding here that concept on this webinar. This is the presentation that we have oriented for that, and we are going to start here doing first a little basic introduction. But this basic introduction will provide you here what is the evolution regarding the technologies that we have mainly for the electrical sector. In this slide, we are showing here some pictures, and these pictures come from our museum. We have a museum where basically we have all technologies. Those technologies, for example, we have all technologies about the storage for the information. We have all technologies for processing and management and, for example, the old computers. We have all technologies for communication and printing. For example, here the papers that before they were sent physically. And we have also all technologies that today they are used yet regarding they are conventional electrical resources. But it is known that today we have non-conventional energy resources that they are based for sure in renewable items. And in this way, for example, in the background of this system, we have also all technologies for the protection and control systems. Today, they have evolution too. And we are able to identify whole new technologies, for example, the IEDs, are providing additional capabilities for the network digitalization. The additional capabilities will provide access for the information in real time using communication protocols, the access of the possibilities to integrate automation schemes. And for sure, we are having here the increasing of the big data that is basically changing all the day because the dynamics on the network. It is known for us that these technologies have had an evolution, and today we don't find them basically working in the real life. I mean, as you can see here, we have these technologies in our museum. So as a basic example that I have here is, for example, the library. Before we were to the library to carry out maybe a workshop, maybe a research. And this is part of the evolution that the cloud generation is providing us, because today we are able to find the information on using the web services too. So it opens different doors. It opens, for example, different applications regarding the storage of the information, regarding the social media, regarding the information, and for sure, we are adding here how the different applications about the power system simulation have been migrated to the cloud too. So I am presenting here some advantage that we have: the storage, the information, the communication, the processing, the control, the automation schemes, the different management systems that we could find here when we identify how the cloud computing opens different opportunities for the network's modernization. This is our new cloud experience. Well, once I did that introduction, let me present here how here we have an illustration of the small microchip. And the small microchip presents here, for example, how it allows to implement some, for example, technologies on the measurement devices, controllers, technologies for the communications, sensors, servers. And in general, we are having here an approach about the technological development. And this technological development has promoted the new generation about the artificial intelligence. And the artificial intelligence is for sure that we would like to illustrate here as the fourth revolution. So this graphic presents, for example, how we have here a first revolution. That was when we have here the machines. We have a second revolution with the penetration of the electricity systems. We have a third revolution when we have here the computing systems. And for example, finally, we have here how we are opening the new opportunities about the artificial intelligence. This fourth revolution is also known as Industry 4.0. It is called basically with that name because that is part of the fourth revolution. In this fourth revolution, different applications are being integrated directly on the electrical networks. For example, we can see how the renewable sources can be managed using the digitalization of the information. And it opens different opportunities, and mainly, for example, for the smart grids. where we need to implement some automation schemes for the power energy management, for the management, energy management system, for the protection device management system, for the assets management systems. And this kind of application, for sure, they use the information. And if the information can be accessed directly wherever you need and whenever, for sure, we are having here new approaches that they are part of the reasons because the utilities are migrating to the cloud. For sure, we have also here some developments for the mobile applications, the augmented reality, and for sure, we are trying to illustrate here that adding here the different pillars that I have here in this slide, we will be opening the door for the electrical sector in order to implement automation scheme and for sure the artificial intelligence to the network. Different pillars and they are part of the Industry 4.0. For example, this webinar is oriented to the cloud computing. We have another applications regarding the augmented reality, the big data, the robots, the simulation, systems integration, the Internet of Things, the cybersecurity. And these kind of applications, they are opening possibilities for the smart grids. We are trying to follow real-time simulations. We are having here the digitalization of the network that allows to implement some automation schemes based on the communication protocols and different resources that I am going to present at the end of this presentation. All these pillars we are covering with this solution about the power system analysis tool that NEPLAN is presenting today. NEPLAN is offering all the pillars that are part for the Industry 4.0, and NEPLAN can be integrated directly on different applications like the SCADA systems, and it changes some opportunities because the network planning can be done directly in the online simulations, not just for the offline simulations. If we cover all the pillars of the Industry 4.0, easily we can say here that the fourth revolution can be for sure, can use for sure the NEPLAN services in order to allow the improvement or the modernization of the networks. The technical reason of that is presented in this slide. This slide presents the architecture regarding the interoperability about the communication between different devices and different servers and different softwares. The communication here, for example, in the substations between the devices is done, for example, using communication protocols like the IEC 61850. Data concentrators in the substations will allow to implement SCADA system, EMS system, DMS systems, all the applications that we find conventionally on the network's operation. And in this level, that is the level that even is on the top of the common information model. In this level, we find here the web services and the application directly on the layer that uses the application on the or the information directly in different web pages. And this kind of applications will allow to understanding that we can have an interaction between different web pages, and it offer different possibilities on the interaction of the database. If that is not clear with this slide, it will be easier to understand here. Because on the network, we find technologies. We find technologies that offer possibilities about the digitalization of the network, or more specifically, about the information in real time. The AMUs, the IETs, the AMI, the PNUs, and other kind of technologies that are able to send the information through the digital systems. And finally, we will be able to concentrate the information here on our SCADA. If we can use that information and we can add some calculations, we are opening easily the artificial intelligence for the electrical networks. And that is done for sure using the power system analysis tool that is able to communicate with the SCADA system or another tertiary part using standard formats, using communication protocols like the web services, using the common information model. This is an example of that. This is a microgrid, and we have this microgrid in our laboratory. This microgrid has the synchronous generation, has the external grid connection to the external grid, has the solar generation, and has a load. For sure, we would like to add here an automation scheme for that. We implemented here an SCADA system, and this is an SCADA system that is our own development. And using this SCADA system, we are able to operate remotely the microgrid. However, if we need to add a smart system for the microgrid, we are proposing here some automation requirement, for example, for the energy management system. The automation requirement means, for example, that if I can do an state estimation in real time based on the information that is going to the SCADA system, I can set an optimal power flow as a tertiary control of the microgrid, and finally provide here the optimal solution of the behavior of the system. The question is, how can we do that? How can we add a smart, or how can we add or develop an automation scheme for our systems if our SCADA is just receiving the information? For sure, that we did was to add a service reference that provides the calculations and for sure the information about the mathematical model. And we just added here some lines, and those lines are providing here a communication in an interoperable way that is offering here the possibility for interaction of the information between our reference and for sure our SCADA system. So let me focus here in this reference. What is this reference? This reference contains the network. This reference contains all the information the information that has been collected on field, nameplates, length lines, short circuit impedance, whatever information that has been processed, and it allows to implement databases like the GIS. And this kind of information can be modeled in this reference of the server. And this reference of the service will allow to get results, will allow to get data regarding the electrical model or mathematical model of the system. And for sure, the operational state that is being sending the information in real time about the optimal power flow solution. Our clear message here is that this reference is easily implemented with NEPLAN. NEPLAN is a solution on the Industry 4.0. Once I did this introduction, let me explain you something. Because today we are speaking about cloud computing, we are speaking about client-server architecture, but it's convenient to mention what do we mean about our real client-server architecture. And starting for that, the cloud computing concept. Let me explain you how here the cloud computing concept has three main topics. First of all, the availability for the storage of the information. Google Drive, Dropbox, whatever kind of servers that will allow to storage the information to be accessed, I don't know, from home, from work, wherever you are. Processing, because if we are using the services on the cloud, we are able to use some architectures where the hardware is provided as a service. And when we use the hardware as a service, we are using remote processing capabilities. And we are able to increase our capabilities of the processing. And finally, the applications. In my opinion, different web pages are applications that have been developed for the specific purposes. And these applications have four main topics that I am presenting here. First of all is the availability of the information, the security of the information, the communication between different servers, and the resilience. A very good example for the resilience is for sure the information. If I have my information in my laptop and my laptop fails, I will lose the information. But if I am using cloud computing and I am using remote servers for the storage of the information, if my laptop fails, I won't lose the information. And finally, for sure, if we are speaking about the artificial intelligence, let me speak about the possibility to implement automation schemes. Give the autonomy of the network. That is what I want to present here in this asset, that is the transmission line, where the transmission line is having here like the thinking, like the possibility to receive the information in real time. And this information will allow you to implement asset management systems, variable rates, smart metering, smart grids, automation schemes, demand response, energy management, all these kind of applications that uses information in real time. And how does it work? It works using client-server architecture. The client-server architecture is basically illustrated here. We use a database, and this database is having a centralization of the information. This database will consist basically on the electrical model, or for sure, it also will have the information of the asset management system about the condition, about the importance, about the features per asset. Using this information, we integrate here an application, and the application will use the database. But you can see that this is an application that is on the server, and the server is connected to the cloud or connected to the internet. And finally, the clients will access to the server using the intranet. As you can see here, the application is not on the client. My question for you attendees is, where is your software installed? Is your software installed in your laptop? Because if the software is installed in your laptop, you are not using a client-server architecture. There are different ways. For example, if we are, for sure, we can install the software in the laptop and we can integrate additional technologies that will provide like a synchronization of the database. That is one example of the architecture. But really, where is being doing the simulation? The simulation is being doing in the server, or is being doing in the client? In this real client architecture, the simulation is being doing in the server. You can have a small laptop, you can have even your phone. You can use your phone because your phone is not using the resources of the hardware. You can use your laptop, whatever, but of course, this kind of importation of databases like the SCADA, like the XML, whatever, will always be interacting the information on the server. If you are using a power system analysis today, please ask the question, where is the software installed? Let me show you here, for example, how you can access. I have here, for example, a web page. And here, how can you access to the NEPLAN? Easily, you can add here the URL. I open my Google Chrome, my Internet Explorer, my Mozilla, and I can go to the URL. And the software is here. Install the app. If you install the app, finally you will be accessing to the software. The software is not using my resources. The software is using the resource that is being provided in this server that has set this URL. Okay? It is easily like opening your email. Your email, you can access your email wherever you are. It's the same topic here. So I am going to present here an example for that. For example, we are using our solution as a GIS tool, where basically we can plan the network directly on the map, and I can work here and run any simulation. This simulation is not doing in my laptop. This simulation is being doing on the server using the client server architecture. Okay. That is the message that we have here, where basically the software is on the server. If you would like the software on the client, you will need to install the software on the client. That for sure, this is an opportunity. And for sure, if for any reason you don't have any connection to the network, you don't have any connection to the internet, and you need local solution, for sure, you can install that. How does the software work? The software works with SQL database. And the SQL database can be locally or can be remote. Well, features that we can use if we apply the cloud computing features. One of them, if you are using a power system analysis tool, my question for you is, do you need to open the whole network? If you need to work power flow, or you need to work short circuit, and you have a big network, I don't know, 80,000 nodes, 100,000 nodes, you need to use your hardware resources for the simulation of that big network. Because if we are able to use the real client server architecture, this architecture of NEPLAN will provide you the option to open any part of the network, just that part of the network. If you need to work with a specific substation or feeder, why do you need to open the whole network? You just need to open the feeder. And you will use the hardware processing on the feeder, on that feeder. Big data and the database and the processing in real time is the opportunities that we are having with this real client server architecture. And for sure, as I have been mentioning, you can use directly the GIS system, and you can export the data to a local solution. Another advantage that we have here is the real-time simulation. Our dynamic simulator is able to work in real time. Why? Because we use the cloud computing features. We can use parallel computing. And for sure, if sometimes you need to work in faster simulation, the parallel computing is perfect for that. The another way is the online simulations, because online simulation is, okay, I can use the information that is coming from maybe measurement in real time, or it can come from historical profile, and the online simulation will allow, for example, simulation like the reliability of the network, like the power flow, like the hosting capacity, or whatever engine that you need from NEPLAN. And this information or this simulation comes from the real-time data, or the data in real time. So, okay. And here, this is a very way that I used to recommend. Because if we are speaking about network planning, if we are going to plan the network, for sure, the offline simulation is mandatory, because you are not using data in real time. You are planning the network, and for sure it can work with historical data. But if you are going to work with NEPLAN as software to be integrated on the operation of the network, what do you need from NEPLAN? Do you need from NEPLAN the graphical interface? Do you need from NEPLAN the database, or do you need from NEPLAN the calculation? Because if you just need the calculation, you don't need to acquire the licensing. You need just the calculation, and that calculation can be easily integrated to a SCADA system or the GIS system, and I am going to present later. So this is a generation of the power system analysis tool where basically on the operation of the network, you just need the calculation, you don't need the licensing. And we are able to provide just the calculation. Power flow, short circuit, dynamic simulation, contingency analysis, reliability, optimal power flow. Just the calculation that can be easily integrated to your EMS, to DMS, to the SCADA system, variable application as a tertiary part. And for sure, this is the service that we provide, and I am going to explain that later. Sorry. Okay. And finally, the protection device management system. The protection device management system is, okay, I have in real time, or maybe I have in my substation, my IEDs, they have some settings. How can I access to those settings? I can have a centralization of the settings, and I can having an assessment of the protections, because how can I check if the setting is proper or not? For sure, today we are able to carry out a coordination of the protection devices, and that is done offline. But if we are going to compare the real data with the network planning, for different reasons, in some cases, they are not the same. So if we are able to integrate the protection device management system, you can check in real time the settings, and you can assess, and you can have an assessment if that setting is proper or not. Why? Because if you get the setting, the existing current, the existing setting, and you run the simulation of short circuit, you can verify if the setting is proper or not. If that is improper, for sure, you can send the information from the protection device management system to the protection and change the group or change the setting. And for sure, it needs to add here some administration rights, because any person cannot change that. But for sure, the architecture provides this kind of capabilities. So based on this that I have been presented, I have here some advantages that the cloud computing with NEPLAN offers. No hardware acquisition, and you can work with big networks with very complex simulation without using your hardware, because the software can be provided as a service. No software acquisition. You have a SaaS, you have the software as a service, you don't need a licensing. And as I mentioned before, you can get just the calculation. No technical support. Why if you are not installing the software? The engineer sometimes is very complex, the installation of the software, because maybe cybersecurity policies, because maybe the operative system, whatever implication that have the installation of any software. You don't need technical support because you are accessing to the remote server. No limitation on the network size, no local files. The cybersecurity and of course the firewall permissions that NEPLAN offers are very, very highly reliable. Client server architecture, teamwork, and the resilience that I mentioned before. Teamwork is one of the main features that cloud computing offers. Why? Because if you have an offline solution and the solution is installed in your laptop, are you planning the network? For sure that just one person can edit the network because the network is on your local laptop. But if the network is in the remote server and the remote server can be accessed from any person and from different persons, for sure, 2, 3, or 4 people, whatever, they can edit the same network at the same time. They can work together. And here, easy automation, online simulations. NEPLAN today doesn't work just for offline simulations. You can work for online simulations. NEPLAN today is not just for the network planning. NEPLAN can be for the operation of the network. Web services, that is one of the big advantage of this kind of architecture, the integration of the digital technologies when we are speaking about the digitalization of the network. We use high standards for the interoperability. For sure, it uses, for example, the common information model and the big data. Because I mean, the big data is one of the main challenges in this network modernization. Where can you store, when can you have the storage of the information? If you are using your local laptop, it won't be enough. But if you are using a cloud server, easily you can save and save and save and save and save the information, and you won't lose that. Here an example about the graphical representation of the network simulation, where easily you can integrate the network simulation to the external GIS or the own GIS of NEPLAN, because NEPLAN has their own georeference system. NEPLAN has their own map servers. The map servers can be for, I don't know, utilities, can be for the oil and gas sector, whatever. And easily you can check how directly on the GIS you can get the result. And you can model directly on the GIS. And I will show you at the end of this presentation an example about how, this is an example about how the calculation has been integrated directly on the GIS without opening NEPLAN. This is an example about the GIS just needing the calculation. Okay, so let me show you here the example that I was presenting here. So this example is using our microgrid system that I wanted to show here. For example, how the real-time simulation. I have here, for example, the information. In this case, I am going to work here with a load flow solution, and I will work here with the load flow solution. I have here the result, yes, and if we are speaking about the possibility to integrate in real time the NEPLAN calculation, for sure. If I add here to the SCADA system that calculation, for sure that you can check here that the information that comes from the result can be easily added to the SCADA system. And for sure, if we are going to implement here the tertiary control of the network based on the optimal power flow solution, and I work with the optimal power flow solution, for sure that this new result will be sent to the SCADA system as a new set point. It is clear that the difference between the network model and the network model or the result on the network model must be very, very close to the measurements in real time. Well, this is a big example. I have here a big example about, for example, how the map servers can be easily used for the distribution networks. And these distribution networks have easily a big networks. I mean, a number of nodes. And if I am mentioning before, if you have big networks and you just need to work the simulation just for a specific feeder, okay, you can work the simulation just for that specific feeder. And finally, the dynamic simulation. The dynamic simulator can work in real time. The dynamic simulator will provide you the solution that in a specific time step, maybe, I don't know, one microseconds, 2 microseconds, whatever, per step, you will be getting the information. And this information can work in real time, and you can set the simulation for specific days or hours on the day. The dynamic simulation of NEPLAN can work in real time. Is your power system analysis tool able to work with the dynamic simulator in real time? So capabilities that the cloud computing offer. And I have been presenting here how the information and the simulation is being doing directly on the cloud. The database is in the external server, and the application maybe that can be easily added to your phone. Well, I wanted to show you this video because this video is an example about the NEPLAN capabilities through the web services and the shape files, because I like a lot this video. In this video, you cannot see NEPLAN here. NEPLAN is on the background, but let me show you here how directly on the GIS NEPLAN is going to work. We have here our GIS, and we are going to look here for the load. We have here the load. And we can change here the view, and we can see here the graphical and the map. And it is easily noticed that that is a GIS on the city. We can see here the house. And for sure, we can add here information in real time from the GIS. Remember, the GIS doesn't simulate. The simulation is going to come from NEPLAN. So we can add here some parameters to the GIS, and we can send here. And after that, these results, they are not being doing from the GIS. These results come from NEPLAN. Okay. As a conclusion for this presentation, I don't know if you remember this microchip. Because if we are going to speak about the small microchip for the artificial intelligence, my answer for you is that this microchip is NEPLAN. NEPLAN is providing you the calculations directly on the cloud for implementation of any automation schemes, or for the storage of the information, for the implementation of your energy management system, your asset management system, and your protection device management system. This is our message for you attendees, where the current NEPLAN architecture is the only one in the market. For sure, we have different approaches for the client-server architecture. The software as a service, the NEPLAN features that is providing through the own architecture that have been implemented with NEPLAN 360 is the only one in the market. So my question for you, if you are in the electrical sector, maybe for the utility, maybe for the industry, or maybe for the oil and gas sector, if you are doing a modernization of the network and you are implementing some digitalization systems, please take into account that the NEPLAN architecture is providing the requested functionalities using cloud computing. And this is what I wanted to show here. Today, we are speaking about the Internet of Things. If the information is directly on that layer, for sure, NEPLAN can work online using the information that is directly on the cloud. And today, all the information is going to the cloud. Our services are oriented to that. We have a very, very wide range of software tools to be integrated to the GIS system, to the SCADA system, to the asset management system, to any tertiary part. And our services are not just for the supplying of the software. Our services is for integration or implementation of any automation scheme on any pillar of the industry 4.0 that I presented before, directly on the modernization of your enterprise management systems. And for sure, we have a big theme that is being working from many years, around 25 years, developing this kind of simulation of applications that NEPLAN is being promoting. So this is the presentation that I have today. Gabriela, I don't know if any attendee has any questions, so I am here very, very open to answer the questions. So I just wanted to mention too that after this webinar, I will share a PDF file. And that PDF file has a summary about the different concepts that I have presented in this webinar. And for sure, it presents how the NEPLAN capabilities with the cloud computing will reduce your cost. So I will send that PDF after this presentation. Thank you very much.
Thank you very much, Leineker, for that very informative presentation. So right now we'll begin with the Q&A portion of the webinar. Here we have a couple questions that were submitted. The first one here says, what are the benefits and the costs for using software in the cloud?
Okay, no, that is basically that I have mentioned right now, because for sure, I'm sure that the PDF that I'm going to send is very clear. But in my opinion, they are different ways to reduce the cost. The first cost that is going to be reduced is the licensing acquisition, because maybe if you are going to plan the network and you are a consulting company and the project will take just 2 or 3 months, why do you need to acquire the licensing, an indefinite licensing? You just need the licensing or the software just for 3 months. So the cost will be will have a very high reduction, because it is not the comparison between an indefinite licensing and the software just for 3 months will reduce the cost. Another topic is, as I mentioned before, you don't need to acquire the hardware. You don't need to buy any hardware, because the hardware is provided from the supplier, in this case NEPLAN. So you will have also that reduction in the cost. Another thing is the technical support. If you don't need to take in many time or a lot of time doing the installation of the software, of course, you will have an optimization of your time. So they are different examples, Gabriela, but I'm sure sharing the PDF file that I have mentioned, for sure that you will get more tools to detect how can NEPLAN reduce your costs.
Okay, great. Thank you for the answer there. Our second question here says, which functionalities would you recommend for the distribution networks with high penetration of renewable sources?
Well, first of all, it is known for us that the renewable sources, mainly the solar generation, the wind turbines, they have a specific behavior that is very unpredictable. I mean, we don't know, or we cannot dispatch this kind of generation. And these kind of challenges have many requirements that the cloud computing offers, because easily we need to implement state estimation or online simulations that will get the information in real time about the penetration of the generation in real time from these kind of sources. So my first recommendation is the state estimation based on the power flow solution. My second recommendation is the optimal power flow solution. That the optimal power flow solution has been very easily used during the years for the transmission networks, but today we are having generation directly on the distribution networks. So my recommendation is also having an approach of the optimal power flow to the distribution networks too.
Okay, great. I'm sorry, go ahead.
Thank you, Gabriela. No, I just wanted to mention finally the hosting capacity. The hosting capacity is for the network planning. That is not mainly for the operation, but just for sure, it will allow you to detect abnormal conditions previously. And the hosting capacity will give you some indicators, like, I don't know, are you able to connect your PV system or even your wind turbine for a specific pole, or a specific location or a specific substation? Because in some cases you need to validate your overloadings, your overvoltage, and really if your system will support this kind of penetrations. So these are the main features that I can recommend, but for sure NEPLAN has many calculation models that they are oriented to the simulation of renewable sources. For sure, the dynamic simulator, I can recommend that module too.
Fantastic. Thank you very much for the answer to that question. So, okay, that concludes our webinar. So thank you very much to all of our attendees. This webinar will be recorded and posted to our YouTube and social media pages, so feel free to check those out. And also, if anyone has any questions regarding this topic, you feel free to send any comments to the email here listed on the slide. And thank you very much, Lenike, and I hope you all have a good rest of your day.
Thank you, Gabriela. Thank you for all attendees. Have a good day.